I am from Germany. We have a small studio there. And as he said, I have a background in television and live production, lighting. And before that, I went to the university for computer science. After switching back from TV lighting, it is interesting to see how much you can take from this and put it into games, which is exactly what I do. So we want to talk about the Shadergraph and make a nice ice surface. So let's get started on that. So we will make this beautiful ice surface we can see here. And this is done with Unity 2019.3. It just released like a week ago in pre-release. We will use the Shadergraph for this. What I did here, I just started a new project with the sample and the preset for the HDRP setup. So we are still in the sample scene, and I put the finished material in. All I did with the sample scene was to deactivate the example assets and the light probes. We will not need that. We are using the sample scene for now because then all the volumes are already set up and we don't need to worry about that for now. The finished graph will later look a little bit like this, but don't worry about that for now. We will go into that. So let's disable that and start new. First, we want to have a 3D plane where our ice material will be on. So this is our plane. We will reset it. Whoop. There we go. For that, we will need a material. So I have here a materials folder where I will just create a new material. If I can find it. Let's call that cracked ice talk for now, because the other name is taken. And we put it on the plane just by drag and dropping. So obviously, we want to have a shader graph, so let's create one. I have a folder here for shader graphs. We will create a new shader, and we will use the HDRP lit graph, because we want to handle all the reflection from the sun and all that, so we need the lit graph for this. So this view is then the shader graph. And we have here, is that readable? Not really. OK, there's nothing I can do about that. This is the lit master node, where we have to connect all what we are doing. Over here, in this panel, you will expose the parameters to take in effect what you do in the editor. Over here, it's just a little preview of how the material will look. For now, we can just set a color here. Safety asset. You will have to always save the asset. There is no autosave right now. And go back to the scene. And as a final step, let's take our material here and change the shader to our shader graphs and the talk shader. And there we go. Good eyes. So I'm done. Bye. So let's see what we actually did. So we start a new HDRP project. We disable the example set assets because we don't need that scene. We import an asset package that is the textures and some sky, which I will show you. This asset I prepared for you to download. In the last slide, there is a link. You can make a photo. You can download the package and try it at home yourself. We created a plane and put a material on that. So let's make a graph. First, color does not really suit us. We need a texture for that. So we create a new node, which will be the sample texture 2D. And there we can choose a check texture. All these materials are in the package, and you will get them. and we will choose the color map for now. We can connect that output directly to the base color. If we save that asset now and have a look, yeah, this is how you get a texture use in the shader graph. Right now, nothing is right here. We see the directional light reflection on that, so that we almost cannot see the colors. We have no depth whatsoever. We have no cracks. These are the cracks we want to use. For the lighting itself, by the way, I should mention that. I changed the directional light for a high color temperature, so it is actually more like the sun, and we get better colors out of that. And I changed the angular diameter, so it is not so narrow. We have a bigger impact, actually, like the sun would have on a surface like this. What I also did is I changed the standard Unity skybox. The skybox I use is also in the asset package. It's just a cube map, an HDRI cube map, yep, that you can use in this. You set this in the sky and fog volume, and just choose it here in the HDR sky box, and we use the daytime. If we have time at the end, we can also look how the material will look at sunset or at night. So, how do we get actually that the cracks, like in my first image, go down in the ice? What we have to do here is a parallax distortion. We want to move the cracks along the normal of the material, aligned with the view axis, down. So how do we do that actually in a shader graph setting? So, as we just saw, we will need the view direction for this. So we can get a node for that. Here we have the view direction. Here you can choose, that is really not readable. It says world here, that's the world space. And we have to switch it to the tangent space, because we want to move along the normals of the material later. We will then expose a new parameter and call it our parallax offset. This is how we do that. We can give it a default value here. Let's stick with something like 2. And by drag and dropping, we have it in the scene. What we do now, we want to multiply those two nodes. Just plain and simple, have them multiplied. And we want to feed that. That is now our offset. We want to feed that in a tiling and offset node. Because then we tell the UVs actually to be something else. Tiling offset, there we go. And we feed that in as the offset parameter. So what can we do with that? We want to have another texture, sample texture 2D. We will do a lot of those. And we will choose a mask. We have prepared a mask. Can you actually see that? Let me try to show you that a little bit bigger. So, this is our mask we will use. It's just a black and white map. And of course, we made the cracks that they fit the location in the color map. We fit this in as the UVs. And then we want to blend it with the rest. If you blend it now, that is really white. And it would overlay, in fact, the opposite of what we want to have. So we have to invert the colors. So we have white cracks and black ice. And we choose here red, green, and blue. And then we have inverted the colors. To add it to the color map, we will then use a blend node. On the overlay setting, use our color map. and use our parallax offset with a setting of something like 0.6 and put it in the base color. If we now save this asset, we can see we have some cracks in there, but they don't really do what we want them to do. Yeah, you see a second layer of cracks over there, but it does not really fit. And this reason is that our values are too high. In our material, you remember we just put 2 as the parallax offset. If I take this value and put it way down, then we get something that actually looks like what we want. I am now on 0.16, and it looks like our cracks are above the eyes, not in the eyes. So let's go below 0, and then you can see we actually have something that is useful. But we also see it is very difficult to drag this in the editor, because the number gets really, really low. Right now we are at 0.08 minus. So what we can do to better handle that, we can take our parallax offset here and just move the comma a little bit by dividing. So let's add a divide node. And we will divide it by, let's say, 1,000. So we move the comma by three steps to the right. Fit that in, save the asset. So that looks better, and now we can very smooth handle this second crack over here. So where would you go from here? We created the shader graph. Oh, I skipped a couple of slides. We created a shader graph. We have the lit master node, which is important for later. We assigned the shader in the material to actually use it, and we set a color at the beginning in the shader graph to see what we are doing. So yeah, I already did that. We use textures, a color map. We created a simple parallax graph. We exposed a parameter, so for now we know how to do that. And we blended our result to the color to have one crack. But to do now like the whole crack down, we have to like 10 or 20 times do the same. Of course, we could do that by hand and make a subgraph out of what we just did. You can just mark them, right-click, create a subgraph. That would look something like this, like with the view direction, the property what we had, the multiply, the tiling offset, the sample texture, and in the end we have an output. That is our subgraph. And then we could, by hand, just copy and paste that in and just lerp it together. And that would look something like this, and it will be a mess. Yeah, we have our parallax part that we just did. We put it in like 10 times, always with another offset. Just add that up and lerp it together, blend all together, and then we have a nice set of cracks. That does sound horrible for me and is a lot of work and is not really adjustable. And if you want to adjust like how deep the crack goes or how how the resolution will be, you cannot really do that. You always have to make a new graph. So let's iterate. Let's write a little bit of shader code, but don't worry, it's not much. So we have here our parallax subgraph. I already created that. You will do that by just mark what you have there, like this. You right-click it, and you can convert to a subgraph. I prepared that because we will need that maybe later. This is how to do a parallax with a shader graph. But for now, we don't need all that. So let's just remove it. Instead, we will use the custom function node, which let us allow to inject some of our own shader code to the graph. We can set here, by clicking on the little icon in the top, open a list of properties. First, we have inputs, and then we have an output for this. And let's just try to recreate what we did with the nodes. So we have a parallax offset. And what else did we have? We had a view direction. And by the way, always press Enter here. If you now just click here, and actually it works now. Sometimes it does not save it when you don't press Enter, and then you have a lot of exposed parameters in your custom shader node that are called new. And you look for hours, what is wrong? No, that never happened to me. The view direction is a direction, therefore it is a vector 3. So let's expose a vector 3. We need a texture to do that, all that on. So let's do a texture 2D, and let's call it the mask. We also need to know where exactly we are when sampling through the shader graph. So we need the sampler state in this, just to pass that on later. So let's make the sampler state, call it SS. So next, we need texture, is that the view direction? What do we need? Oh yes, of course, we need the UVs. UVs are a vector 2. And of course, because we want to iterate, we need a parameter that is called iteration. So that will be our input. And as an output, we will just have a vector 4, which will be a color. We will call that out, like this. So we now have to give that whole thing a name. We will call it parallax loop talk. And as a source file, we will not use a file. We will just use a string and enter the shader code right here. It is not much, so we can do that. But I think you cannot read that at all. Let me just increase the font size. Can you read that? Good. So we write it in the text editor. So we will start with the float 4, call it result. And to have something to work with, we will initialize it with just white. That will be just white. We want to iterate through our offset, so we need some variable to store our offset that gets bigger when we go down. So we need a float for that, and we call it the total offset. Then we need something to store our current math step in. And we are working on a black-white map in the end, so just a float will do. Black-white. So I will do it now for one step, so exactly like the shader graph was before. And we will do the iteration later. But let us think ahead and already pretend like we are iterating. So we have the total offset, and that is plus equals our parallax offset, which we defined as an input variable to this shader node. We want to calculate our offset. Like in the shader before, we multiplied it with a view direction. So let's store that in a float. That is a direction, that is a float 2. So we had the view direction multiplied with our parallax offset, in this case, the total offset. And from that, we will just use the red and green channel. Because the view direction is a vector 3, multiplied by a number, it's still a vector 3. So we can use red-green in shader code for that. Then we have to sample our texture, like in the shader graph, exactly. We want to store that in our black and white value. And for that, we call the function sample texture 2D. And that wants to have the texture it's doing that on, which is the mask. It wants to know the sample state, which we can just give it. And then it wants a set of UVs. And for that, we will take our UVs and add our offset to this. Basically, just like we did before with nodes. Store this in our result. And again, we think ahead for the iterations, so we do it like this. And in case we have some numbers that are bigger than 1, we will clamp it, take our black and white mask and clamp it between 0 and 1. Adjust our alpha, because we want it to be visible. And give all to the out. That is exactly what we did before with the nodes. So let's take all this. And put it in here. So all we have to do now is connect the dots. So we put in our parallax offset, like before. We put in the view direction, which we had. We choose a texture, which is our mask, like before. We create a node for the sampler state. Sampler state. And connect this. We want a set of UVs, so let's get that with a UV node. And the iterations right now don't really play a role, because we don't use it. So we connect our output to the invert colors, and we have actually, when we save that, the same as before. It's always good when you put a lot of work in something that looks exactly like before. So let's iterate on this. We want a new expose parameter for this that we will call, it's at vector 1, and we call it iterations. Give it like a default of 10, so we always do 10 iterations. And drag and drop it onto the graph. Connect it to the iterations. We go again in our shader code. Now we can do a very simple loop, like for int e or for those who feel better with this, we can do this, but I don't really want to start that discussion right now. and close the loop over here. Oh, that was a reflex to save it. Take this and put it back in our shader code. What did I do wrong? Ah, live coding, what can go wrong? This is actually called iterations. There we go. So now we have a lot of cracks. They are far apart, so we adjust our parallax offset, make it a little bit smaller, and there we go. And let's go crazy with this and do like 100 iterations. And move it even closer together. So like this. So there we have some nice looking cracks. But we are not really satisfied with this. Right now, these cracks all have the same opacity all the way down. And they should get more transparent the deeper we go. So let's just add this to our shader code by just adding a fraction to the mask. Like this. And then we have something like this. And as we can see, when we move along, the parallax really does work and give us the impression that we actually look in the depth of the ice. So let's summarize what we did. We created a custom node with a lot of parameters. We wrote a little bit of shader magic. And that was about it there. The shader code really was not that hard. We just followed exactly what we lined out with the nodes before. So let's add some details to this. For those of you who are familiar with the PBR workflow, that is now not really that thrilling. We want to add a normal map by just create a sample texture, because we need the texture. Choose our normal map for this. Don't forget to change the type to normal. Yeah, that looks much more like a normal map. Connect that to the normal map. Whoop. Save that. And to no one's surprise, we have something like these little surface unevenness in this that comes with the normal map. But of course, that does not reflect like ice should do. So what we will do is add a metallic map. So we create another sample texture. That should all be relatively straightforward. And we take the roughness. We did all the textures with Substance Designer. So Substance Designer works on a roughness workflow, but Unity works on a smoothness workflow. So let's get smooth in just inverting the metallic roughness map. So the already familiar node invert colors. And we connect our texture and red, green, blue. With this, we can go in the smoothness dongle and make sure that metallic is 0. Save that asset. And now we have something that looks way more like ice. I skipped the summary because it was just adding a normal and a metallic map, so nothing more. But let's speak about more details. In real ice, that is a picture of real ice that we find, I don't know, on a sea or in the northern sea or in a lake. And you can see that there are little particles in the ice, like algae or plankton or some dirt that gets stuck in the ice, gets frozen, and builds these little clouds of dirt that is down in the ice. So let's try to add this to our ice map. Down in the ice does sound for me like a lot like another parallax distortion, which is exactly what we do. Make a little space here. It's the kingdom for OCD. Yeah, but how do we actually do that? We have a subnode that we created earlier. We will find that on the subgraphs. And we have here our parallax subgraph. Here we go. So it needs a texture. For that, we can just use a simple noise map, something like a pollen noise map. You can download those on the internet, and it's also part of the package, but to create a parallax noise, it's really not that hard. But instead of the cracks, which are all on the same level when we move them parallax, we have the cloud, and the cloud is in variation of depth. It's like this in the ice. So how do we get this? We have our parallax offset, so we will just modify our offset. And we will do that by creating a simple noise from the Shadergraph. There we have it. And we will scale that a little bit down so that we have, I don't know, 40 maybe, something like a nice cloud here. And we will lerp that, so add a lerp node, and use this as our t, because it gives us values between 0 and 1, so we can use that very easy to lerp this. And we will lerp between minus 0.2 and minus 0.25, which are values that I just tried in the editor. You can use the values you had before for the cracks. We had some very low values there. And connect this to our subgraph. We again have to invert the colors. Oh, that is also to your liking. You don't have to invert the colors here, depending on how much dirt you want to have in this map. And you blend this with, oops, I don't want it to make a note. So we need another blend node. Again, with the overlay setting, we connect what we had before as the base and blend in our color and use again like something like 0.5, 0.6. You can experiment with these values, and if you want to experiment with them from the editor, you just expose it here and connect it, and then you can do it in the inspector. And the result we will connect to the base color. We don't need to adjust our normals and our metallic stuff because it's down in the ice. And normals and metallic is only on the surface. It will just give more surface information. We don't care for our dirt here. We don't care about that. And we have little, very subtle, can you even see that on this resolution there? Some dirt clouds there. Of course, you can make a more elaborate texture for that, depending to your liking. That is another detail done. So, to summarize again what we did there, as our parallax offset, we used a noise map and lerped the values so that they are useful for our graph, so we have this unevenness in the cloud. If we would not do that, we would have the cloud all on the same level, which would not look realistic. We blended that together with the rest of the colors. What we did basically was add a parallax cloud, and we blended it to color. Let's add snow. In nature, when you have an ice surface and there are little cracks in there, where the crack is, there is an unevenness, and wind can drag like little crystals, little snow in there, which will over time accumulate to some snow patches. I have this picture here. We have also some cracks, and you see the snow patches. And let's try to add that to our ice surface. Go back to our shader graph. And we add another texture. That is a sample texture 2D. Another one. There we go. And for the snow patches, I just made a black and white map, which has just some snows and even some white lines, a little bit, where the cracks are. And since this is black and white, we can just add this with an add node to our color. And as simple as that, because 0 is actually black, so we have no information for all the black parts, we can just add this to the color. We will save that. And look at this. So we have some snow patches. But where's my sun there? You see the problem here? The sun actually reflects the same on the ice as on the snow. And if we go back to our picture, we can really see in this picture that we have no reflections on the snow. You see the mountains on the ice, but the snow, there's no reflection. So we need to adjust our normals and our metallic surface for this. We jump back to our graph. Handling the normal first, because that is easier. In fact, it's both easy. We need another texture for that. So for that, you can just create a normal map for the snow, and you have already some information in there. Let's choose the snow normal, and again, tell them it's a normal. We cannot just easy blend this together. For blending normals, you need the normal blend node. So instead of the normal blend, we use the normal blend. Pun intended. Where we can connect two normal blobs, and it will give us a nice result for the normals. So, now for the metallic part. For the roughness textures, we use black and white maps. And the snow is already a black and white map. So, like with the color, we can add them together. And then we invert it. So we have black parts where the snow is. And now we have this effect where the ice is not even. There's little snow in it that maybe melted a little bit, got frozen again, and now we have this twilight effect with blinky snow, and no reflection where the snow patches are, which is exactly what we wanted. So that was a straightforward step. We added a snow map, black and white, to add it to the color, because black has no information there. We added a normal map for that, and blend with the normal blending. And we also added our snow to our roughness before inverting to have it blend to the smoothness. At this point, I wanted to see if I have time, which I have. So I can introduce another feature. And we can see this feature already here. In the graph that we made, all the cracks go to the exactly same depth. We put it in, and it goes exactly the same. And I wanted to put it like a little unevenness in how deep the cracks go, to make it more natural. So we will adjust again our shader graph to have the cracks little unevenness and how deep down they go. So let's see how we can do that. So if we want to adjust our cracks, there is sadly no other point to do that than our custom function, and we have to add a few more parameters. To have it more random how deep the cracks go, we can use a noise map. So first, we want to have another texture in here, and that will be, come on, that will be a texture 2D, and we will call it noise. To have a little bit control on how that behaves with the cracks, we want to scale that noise map. So let's introduce a factor for this to scale the noise map, which can be a vector 1. And it will be our noise scale. And finally, we want to adjust how much effect the noise has on the depth. So we put in another factor, which will also be a vector 1, for the noise depth. So with all those new things, we can jump back in our shader code. First, we want to store our offset, our noise offset somewhere. So as with the total offset, we will introduce a float that is our parallax noise. Then we need to generate an offset almost like we did for our normal parallax distortion and store it in this parallax noise. So, like with the black-white map, we use the parallax noise. And we will sample our noise map. Again, we need the texture itself, which we called noise. We need the sampler state, which we already have, and we need the UVs, which we want to calculate a little bit. Basically by the offset as before, but then we want to multiply it with the scaling. Is that right? That is right. And we scale it in the texture sampling, noise scale. We scale it in the texture sampling because we want to adjust how far this, if we have little dots or big clouds in the noise texture. Then we want to adjust our black and white map with this. So we add this to that, our parallax noise. And we want to adjust how much influence we have with this, with our noise depth. So we multiply it by the noise depth. So if we put a value of 0, we have no noise, and it will just be look as before. And that is already all we have to do here. For our noise map, we can again use the Perlin noise. But of course, you can add any noise map or other textures you want there, as long as they are black and white. And we will expose 2 more parameters for this, both vector 1, namely the noise scale and the noise depth. And there we go. Save the asset. And we can adjust some scaling to this. And if we now, let's try a good spot for this, play around with the noise depth, we can see that we get an unevenness in this, which gives us then this look. Yeah, we made some noise with cracks. It was a little bit of shader magic. Nothing too fancy. We just added a noise step in our calculation of the depth. Done this time for real. Just a second. What you can do with this, because the materials we made for you to download, they are tileable. So you can make a big ice surface, and of course, if you do more fancy textures, and because they share the material, the calculation is done once. And you can have a giant surface of ice with this effect, like this. And our finished graph looks something like what we also made. You can now take a lot of time to make it look pretty.
Thank you very much. I think Jens will be available during the whole conference to ask some questions a little bit later.